In this lesson, we're going to look at compound interest, which is the other way to calculate interest. So in the previous lesson, we looked at simple. In this lesson, we're going to look at compound interest. The formula is given as A, which is the total amount, equals P. Again, that's the principal, just as in simple interest, starting amount. And then we multiply that by a common ratio. So remember, this is an exponential equation. And all exponential equations are in the form a times b to the power x, where a is the start amount multiplied by a common ratio, and then a certain number of times. So 1 plus I, the 1 is actually representing 100%. So 100% means your starting amount. So if we multiplied P by 1, we would get P. So 1 is representing the starting amount, and then we're adding on the interest. And then N is the number of times we're going to do that. So the most important thing in compound interest is the I and the N, because they will change according to how often we compound our interest. So we could compound our interest annually, which means once a year. We could compound it quarterly, which means 4 times in a year. We could compound it monthly, which means 12 times in a year. Or we could compound it semi-annually, which means twice a year. So how often it's compounding is very important with compound interest. So for example, let's say we invested $1,000 at 6% per year for 4 years. The amount is not going to change. It's going to be $1,000. The interest rate is not going to change. It's going to be 6%. And the number of years is not going to change. It's going to be 4. But what happens with the interest? So if we think of 6% as a decimal, so let's divide by 100, so decimal 0.6. So the interest rate will always be 6%, but we are going to divide that by how often we are compounding. So if it's once a year, we'll divide it by 1. If it's 4 times a year, we'll divide it by 4. If it's 12 times a year, we'll divide it by 12. And if it's twice a year, we'll divide it by 2. The N is the number of compounding periods in total. So if it's once a year, it's 1, and then the number of years is 4. So N's going to be 4. If it's 4 times a year, it'll be 4 times a year for 4 years. So N will be 16. If it's monthly, it's 12 times a year for 4 years. So N will be 48. And if it's semi-annually, it's twice a year for 4 years. So N will be 8. So when we put this all together, we're investing the same amount of money, $1,000. The interest rate, in the first one, it's going to be 0.6 divided by 1. In the second one, it's going to be 0.6 divided by 4. In the third one, it's going to be 0.6 divided by 12 because it's monthly. And then finally, the last one, it'll be 0.06 divided by 2 because it's semi-annually. And then N in the first one is 4. In the second one, it's 16. In the third one, it's 48, and in the fourth one, it's 8. So what we want to see is, does this make a difference in our answer? So remember that we're investing the same amount of money at the same interest rate for the same period of time, but we're compounding it differently. So let's calculate the first one. So in the first example, if we calculate it once a year, we'll end up with $1,262.48. So we've earned $262.48 in interest. If we do the second one, this time we're compounding it quarterly, so we're going to divide that interest rate by 4, and our N is now going to be 16. And we're going to end up with $1,268.99. So you can see that we've made a little bit more money. In the first example, it was $12.62. Now it's $12.68. So we've made a bit more money by compounding it 4 times a year instead of once a year. In the third example, we're going to compound it monthly. So we're going to divide that 0.06 by 12. And our n is now 48. So now we're going to earn $1,270.49. So again, we've earned a bit more money by compounding it monthly instead of annually. And then finally, in semi-annually, we're doing it twice a year. So we're going to divide that 0.06 by 2. And it's going to be 8 times in total, 1266. So you'll see that annually we earn 1262, twice a year is 1266, 4 times a year is 1268, 12 times a year is 1270. So remember that we're investing the same amount of money at the same interest rate for the same period of time, but we end up making more money more often with compounding. So more money the more often we compound. Okay, in this example, we have Aaron investing $7,200 at 4.5% interest semi-annually. So I know it's compound interest because I see the word compounded, and it's twice a year. So how much would he have in his account at the end of 3 years? So my interest rate is going to be 4.5%. I'm going to divide that by 100 to change it to a decimal. So we're starting with $7,200. 1 plus the interest rate is 0.045. We are compounding semi-annually, so we're going to divide that by 2. We are compounding semi-annually twice a year for 3 years. So n is going to be 6. We're going to get compound interest 6 times. Okay, so let's see what we have. So we're doing the 0.05 divided by 2. Add the 1. Then we're doing to the power 6. And then multiplying it by the initial amount of $7,200. So at the end of 3 years, he would have $8,228.34. Okay, in the next example, Alicia invests $500 at 2.75 compounded quarterly. How much should he have at the end of 5 years? So again, I see the word compounded, so I know it's compound interest. The initial amount is $500. The interest rate is 2.75%. Let's divide that by 100. So it's going to be 1 plus decimal 0.275. It is compounded quarterly, so we're going to divide that by 4. And then n is going to be 4 times a year for 5 years, so n is going to be 20. So let's see how much that works out to be. 0.0275. We're going to divide that by 4. We're going to add the 1, and then we're going to do that to the power 20, and then multiply by initial amount of 500. And she would have 573.43 at the end, keeping in mind that the interest earned is $73.43 because she started with 500. So if they ask you interest earned, you just subtract the original amount from the interest. Okay, last question. Again, I see the word compounded. So the original investment is $2,500. The interest is 6%. So let's change that to a decimal. It is compounded monthly, so we're going to divide that by 12. So monthly for 2 years, n will be 24. And then we'll calculate this. So the 6% is divided monthly, so divide by 12, add 1. Power is 24, and then times $2,500 is $2,817, and let's round that to 90 cents.